Algebra 2, Target 15. I can factor polynomial expressions. Today our focus is on the quadratic form. Polynomials in quadratic form. Now you may remember the quadratic, standard form for a quadratic, ax squared plus bx plus c. Now what we mean by quadratic form is we look at the pattern as we go down, and we notice that this is 2, this is 1, and here it's gone. Well, really what's happening is you're cutting it by half as you go down from left to right. Anything that follows that pattern is considered to be in quadratic form. So, for example, y equals x to the 6th plus 3x to the 3rd plus 2 is considered to be in quadratic form because the 6 cuts by half to get 3 and then it's gone. That's quadratic form. You'll always start with an even power, then it'll cut in half and then it'll go down. And generally what we'll look at is we'll substitute that down and get into quadratic form. How do we get 6 down to be a square? Well, if you use u, if u squared, you want it to be x to the 6th, you cut that in half, and let u equal x to the 3rd. So we substitute this, we get u squared plus 3u plus 2, and then that you can factor. So we're looking at quadratic form, we're going to factor those and simplify those, or substitute those and simplify those down. So this kind of sums it up. Quadratic form, a u squared plus bu plus c. You start at 2, it gets cuts in half, and then it's gone. Anytime you can substitute down to get that. All right, so let's look at an example. Factor completely. Why is this in quadratic form? Well, we start with an even power. And we go down by 2. The middle term's missing. All right, now as we look at it, we can substitute the x squared out. If u equals x squared, then u squared equals x to the 4th. We got 16 u to the 4th minus u squared, sorry about that, 16 u squared minus 81, and we can factor that. Now if you remember your special patterns and you remember your conjugate pairs, this should look like a conjugate pair with difference of squares, because the first term is squared and the last term is squared. And so we can factor this as a difference of squares we get with our two conjugates. 4u minus 9, 4u plus 9, and then we want to remember to go back and put our u back in. So really we got 4x squared minus 9 times 4x squared plus 9. So we notice it follows the pattern of a quadratic. We substitute it to get it to be a quadratic, and then we substitute back to get to our original variable. Now this unit's on factoring completely, so we need to look and we say, okay, are we done factoring? Can we go further? And the answer is yes. On this one, on the left, we notice that, again, we have something squared minus something squared. On the right, we have something squared plus something squared. There is no special pattern for a sum of squared. So the right side's done. The left side, we can use the difference of squares pattern. We got 2x minus 3 times 2x plus 3. And then 4x squared plus 9. And then that's our factored form. So we start with our quadratic form, we substitute it out, factor and substitute it back in. And then we look and we say, okay, are we done? We can go further sometimes, and if we can, we do. Let's try another one. Take a look at this one. Notice we've got common terms throughout. First thing you should always deal with is common terms. All right? Everything has 2p to the power of 2. All right, we'll factor that out. We got p to the 6th plus 5p to the 3rd plus 6. All right? Now, take a look and notice we got our quadratic form because our highest power is 6 and even. You cut that in half, you get 3, and then it's gone. But we want to get rid of the 3rd power and the 6th power. So let's let p to the 3rd equal u and substitute it out. That means p to the 6th will equal u squared. So if I rewrite this in terms of u, we got u squared plus 5u plus 6. I didn't substitute here because that part's already factored, so I'm going to just have it there and leave it alone. All right, now we'll factor our quadratic, and whatever method you use, I'm going to pull it out in the box. U squared here, 6 here. What multiplies 1 times 6 to get me 6 and adds to get me 5. That's 2 and 3. Pull out 3, pull out u, pull out 2, pull out u. So my factored form is 2p squared, u plus 2, u plus 3, and then I'm going to go put my p's back in. We'll get 2p squared equals p cubed plus 2 and p cubed plus 3. And we ask ourselves, can we factor further? The only option would be if these were perfect cubes and there's no number cubed that gets me 2 and no number cubed that gets me 3. So this is my fully factored form. Right, so in conclusion, we need to first notice that it is in quadratic form. Right, and to do that, we need to kind of see our lead power, our degree, is even, and then it cuts down by half as you go from left to right. Once you notice it's in quadratic form, you'll substitute it so that it becomes a quadratic and not just in the form. Then you're going to factor it as a quadratic. And then you'll substitute back to the original variable. And then, as always, make sure you double check after you've factored to see if you factored completely. You may have to continue factoring.